Good evening, guys. Welcome, all of you. Very good evening, everyone. All right. Okay, guys. So, everyone is here. Please once confirm, all of you. My voice is clear to all. We are going to start the practice of more important questions of organic and inorganic. Yes, very good evening, everyone, guys. So, yes, guys, let's continue the practice. This is the revision series, and we are going to have these sessions on Thursday, Friday, and Saturday. 3 days consecutive, same timing. So, in this month of September, I have kept the timing to be, let's say, 6:15 p.m. because yes, usually we have in the morning these sessions, but here in this month I've kept it 6:15 p.m. right? So just be reminded of this. Also, if you want to get all the links on time, then you can join up the Telegram group also. That is CSIR NET 2022. Okay, and yes, guys, without any further delay, let's just start the practice. First question: major product formed in the following reaction is. Good evening, guys. Good evening. Welcome. So you can answer in the live chat. And guys, एक बार resolution बढ़ा लो so that you can see the question properly. Yes. Yes, all right, guys. Very good. So what is this reaction going on over here? NBS in the presence of benzoyl peroxide, isn't it? ये क्या है? It is benzoyl peroxide. So what does the benzoyl peroxide do, guys? It is a radical initiator, isn't it? So you are going to get two of the, in the presence of heat, right? You're going to get two of the carboxy radical in this way, which are going to break down to give you two of the phenyl radicals. Two phenyl radicals plus 2 moles of CO2 gas eliminated. Okay? So this phenyl radical is going to take away a proton from here. All right, and then it's going to give you this kind of a molecule, CH2 radical. And also, guys, NBS, N-bromosuccinimide, N-bromosuccinimide also breaks down homolytically to give you a bromine radical, allylic bromination, absolutely. So allylic or benzylic, whichever you want to call it, there's a conjugated system over here. So this is going to be a stable radical, and after the connection, direct connection, it's going to give you answer as option number A. Absolutely, guys. So if you have benzoyl peroxide or any other peroxide and NBS, you are going to always create a bromine radical. So this is the answer. What about other option? ये गलत क्यों है? Because it is doing electrophilic aromatic substitution, isn't it? It is not the reagent for electrophilic aromatic substitution. Whichever position you take the second position or third and fourth position, fifth position, doesn't matter. All of these are wrong. Yes, chalo. Let's move onward. Let's see, guys. The correct order for the rate of thermal decarboxylation of the following compound is. Another very important concept. Yes, so which decarboxylation is the fastest and which is the slowest? Yes, everyone. So what do you see over here? Upon decarboxylation, what would you get upon decarboxylation? You will definitely get a negative charge, isn't it? Or if we want to write this carboxylate in this way, C double bond O, OH, like this. Yes, this is how you will, you can also write it down. So just like, just like we have beta keto acid, the keto group helps in the removal of the carbon dioxide, just like that. The nitrogen over here by attacking on the proton is helping you in the decarboxylation process like this, isn't it? That is, it's going to take away a proton now, and this is a double bond over here, and CO2 is eliminated. All right, so this is going to be somewhat more stable as compared to option B, isn't it? क्यों guys, क्या हो रहा है यहाँ पे देखो, in option number B when you are doing the decarboxylation. Okay, so nitrogen is not able to help and grab this proton क्योंकि थोड़ा सा strain आएगा, right? Even if you want to write the hydrogen over here, there will be a little bit of a strain when the nitrogen gets this proton, but it is more stable than A because of the minus I effect, isn't it? Yes, so there is a negative charge over here and the proton is taken away by the nitrogen. There is no resonance, but because of the minus I effect, it is more stable than 1A, which is going to just directly have this kind of a carbanion. So that is why this is the order. C is greater than B, greater than A in the decarboxylation. Okay? Yes, very, very important. All right, let's move onward then. Very important question. ये देखो, easy question. The major product formed in the following reaction is. Yes, all right, very good. What about everyone? So we are having the trifluoroacetic acid, which is a strong acid. And what does it do, guys? What does the acid do? Are we going to eliminate nitrogen from here? If we just eliminate nitrogen from here, minus N2, what does that give you? Yes, what is the intermediate that is formed? You are getting a acyl carbene. Yes, you are getting an acyl carbene. So acyl carbene could have rearranged to give you the isocyanate, or let's say the ketene kind of an intermediate. But what happens is, since there is a methoxy group present over here, the double bond on from the benzene ring, it can also attack, and we might get something like this. All right, in this way also it could attack. Right, and the oxygen having a positive charge over here. What happens next? Since there is acid present, it is going to be hydrolyzed. The acid is going to just remove the methyl group from here. Water can attack over here. It is released. Now you are going to have this molecule as it is. Okay, so this is the correct answer. You are not going to have the methoxy anymore. Once the oxygen has attacked, there will be a double bond, right? And this carbon has attacked over the carbene. So obviously guys, when any bond attacks over the carbene, you should say ma'am यहाँ तो negative charge आएगा. Yes, definitely there will be a negative charge. So what is happening, guys? Negative is not a problem because there is an acid, so it can easily take away a proton and it can easily have two hydrogens over here. All right, so that's not a problem. Answer is going to be option number 3, through the formation of a carbene, which does not do the rearrangement, which is directly facing the nucleophilic attack from the aryl ring. Okay. So another important example where carbene is not doing a rearrangement or an insertion reaction. ये देखो, The major product formed in the following reaction is, this is question number 4. So what according to you is the correct answer? Easy question. Yes, so what is the molecule actually looking like? It's also mentioned that how the CBZ is going to look like. CBZ भी क्या है? Carbamate ही तो है. It is also a carbamate. So let's write the carbamate over here. CH2PH and tertiary butyl group like this. Okay. So what's going to happen, guys? Yes, Fatima, screen not seen properly. So Fatima, please once refresh and also increase the resolution. Guys, so trifluoroacetic acid is usually seen for the N-Boc deprotection. ये हम देखते हैं ना, NH-Boc deprotection के लिए यूज होता है trifluoroacetic acid or dilute HCl or some other strong acid, right? Yes, right. But here you don't have the carbamate. ये जो carbamate है guys, CBZ, this has a carboxy methyl group, right? Which means that you are having a benzyl group. This is a benzyl group. And benzyl and heteroatom bond cleavage will take place only in the presence of catalytic hydrogenation. So if you want to break this bond, if you want to free the CBZ group, आपको क्या करना पड़ेगा? Catalytic hydrogenation you have to do. If you are not doing it, this group will be as it is. And this methoxy over here, guys, it is not reactive. Why? Because the oxygen bond is very strong with this benzene, because it is donating the electron density. तो double bond है यहाँ पे, तो ये तो बिल्कुल hydrolyze नहीं होगा, no. And who else is left? The ester is left. So what is going to happen to the ester? The ester could be attacked by the, obviously it's going to be an aqueous acid. So ester could be attacked in the presence of the aqueous acid. It's going to take a proton and it's going to be attacked to free up the acid only. Okay. So fourth is the correct answer. You cannot free the CBZ without catalytic hydrogenation. These two are absolutely wrong. What happens with two? और यहाँ पे मिथॉक्सी ग्रुप को फ्री कर दिया है, which is absolutely not going to happen. Okay. Yes, so answer is option number D only. Very simple, guys. Now let's move on to the next question. And before that, let me remind you all कि फिलहाल जो है आपका Unacademy Lite subscription के ऊपर you are getting this for 6 months and only in 269 rupees by using the code that is Jagriti S Live. You know that already. Unacademy Lite subscription will be helpful for those who are ready to do the practice. They have done all of their preparations. ठीक है, so 6 month के लिए only 269, that also by using the code. Also guys, for all of you who want to do some advanced question practice of all the organic and inorganic, you can join up on Unacademy Plus. The course has already started. It's a very very good course for the last minute question practice. It is on Unacademy Plus guys. और फिलहाल के लिए let me inform you that for all of these subjects Unacademy Plus के ऊपर notes are also available. In-app notes are available for Plus and Iconic learners. Hard copy notes are available for Iconic learners. Okay, accessible everywhere, anytime, curated by top educators. Okay, Also, guys, right now this 20% off is going on the Unacademy Plus subscription. So these are the Plus and Iconic subscription prices that you have to pay for this much time duration after doing 20% off on using the code. Okay? Yes. All right. Chalo, we move onwards. And now guys, we go to the next question. Yes, Vineet. देखो विनीत क्या होता है कि I daily have free sessions in the special class also. You can join up for question practice. तो सब जगह question practice ही हो रही है फिलहाल YouTube पे और special classes में और plus classes में सब जगह question practice कर रहे हैं हम. Okay. So, yes, guys, question number 5. Among the following molecules, the compounds which will behave as a base in liquid HF. So, HF is your solvent, hydrogen fluoride is the solvent. Who is going to behave as a base in the liquid hydrogen fluoride? Acid base chemistry, guys. Yes. All right, guys. Very, very good, all of you. Yes, everyone try this out, guys. बहुत अच्छा question है. So what is supposed to happen? Yes, first of all, let's consider what is supposed to happen when you're taking liquid hydrogen fluoride as the solvent. So first of all, let's look at the self ionization reaction. So 3 moles of HF are going to give you H2F positive and HF2 negative. ये दो ions बनेंगे on the self ionization, right? Yes, good evening, guys. Good evening, who are joining now. So, on the self ionization, you're going to get these two species, right? Whoever forms the positive species, this is the solvocation, it is the solvocation, and this is the solvoanion. Okay, so whoever forms the solvocation will become the acid, and whoever forms the solvoanion forms the base. तो question क्या बोल रहा है? The one of the molecules who are going to behave as a base. So we have to find out who are going to generate this anion in the solvent. Okay. So let's start from water, guys. Water is the easiest one. So if it is reacting with HF, it is going to give you H3O plus and F minus. तो ये भी तो anion ही है. Yes, absolutely, it is going to behave as a base. All right, this is correct. LiF plus HF. So lithium fluoride is a fluoride donor, absolutely ionic compound here. It's going to be Li plus and H2F minus. This is also going to work as a base. Then acetic acid. Let's look at it, guys. So you tell me that acetic acid ज़्यादा strong है या HF ज़्यादा strong है? Who is stronger, acetic acid or hydrogen fluoride? Absolutely, hydrogen fluoride is a stronger acid than acetic acid. So what has the acetic acid got to do? इसको proton लेना पड़ेगा इससे, which means it is going to form CH3COO, H2 positive and F minus, right? So absolutely, this is also working as a base because it is a weaker acid. So this is working as a base and this is working as an acid, right? So ये भी correct है. What about this one? Yes, what do you have, guys? This is very, very simple. You can just draw the structure of this molecule. It is nothing but fluorosulfuric acid. Yes, it is fluorosulfuric acid. So fluorosulfuric acid is a stronger acid as compared to HF. Okay, सो ये क्या करेगा गाइस, ये ना, ये जो प्रोटॉन है ये इसको दे देगा. सो इट इज गोइंग टू फॉर्म H2F पॉजिटिव एंड SO3F negative. ठीक है. So what does it form? It forms the solvocation. So which means that this is going to behave as the acid, not a base. तो ये acid है, बाकी सब के सब क्या है, bases. So this is your answer, option number 4, right? Yes, very important and easy question. Now we move onward to see another good question, guys. The correct order of metal carbon distance is. The correct order of metal carbon distance is. Yes, all of you. Metal carbon distance. So all of these are what? Metallocenes. ये सारे के सारे क्या है? Metallocenes, they are. All right. They're all metallocenes. So we are talking about the metal and the carbon distance. Yes, absolutely. So, what do we have to consider, guys? Iron has 8 electrons plus Cp donates 5 electrons in the neutral method. If we are counting 5 electrons, so 5 into 2 will be 10. तो कितने electrons हो गए iron के लिए? You have 18 electron for the ferrocene. Then cobalt has 9 electrons, so you will have 19 electron for cobalt, and nickel has 10 electrons, so 10 plus 10 is 20. 20 electrons, guys. So where are these extra electrons going to go? हमें तो 18 electron चाहिए on the metal. Where are these extra electrons going to go? The extra electrons go to the anti-bonding orbitals. ठीक है. The extra electron go to the anti-bonding orbitals. Greater the extra electrons as compared to 18, उतने ही ज़्यादा anti-bonding में जाएंगे, which means that anti-bonding is going to decrease the metal carbon bond order and increase the metal carbon bond distance. So bond order decreases and the distance increases. So that is why nickel has the maximum distance as compared to cobalt as compared to iron. ये हमें पता ही है. Bond order is inversely proportional to the bond length. So the same happens over here. Alright. So fourth one is the correct answer. Okay. Yes, we are talking about the distance, guys, not about the bond order. ठीक है. So fourth is the correct answer. Moving onwards, everyone. Let's see this. ये देखो, major product of the following reaction is. Yes, yes. There is any confusion in this question? Less back bonding, more carbon, metal distance. अच्छा, you are saying. अच्छा देखो, simply you can consider like this. इसके पास दो extra electron है as compared to the 18 electrons. When we have seen the metallocene molecular orbitals, जो iron था, it was filling up till the A1G, I guess, right? So yes, 18 electrons filled up till the A1G, right? उससे ऊपर जाएगा, so that was E1G star, right? That was star. मतलब star मतलब कि anti bonding orbital. Okay, so if you remember that we had considered this kind of a energy splitting of the d orbitals. Okay, so till ferrocene we were filling up over here till here, right? अभी ये जितना इलेक्ट्रॉन एक्स्ट्रा होंगे, वन इलेक्ट्रॉन, इफ इट बिकम्स एक्स्ट्रा, दिस इलेक्ट्रॉन इज एक्स्ट्रा, व्हाट हैपेंस, ये एंटी बॉन्डिंग में चले गए. This is the Eg star, right? So if they are going into the anti bonding, then definitely the bond order decreases. Whose bond order? Bond order of the metal and the carbon bond order decreases. ठीक है, तो बॉन्ड ऑर्डर डिक्रीज होता है तो डिस्टेंस इंक्रीज होती है. दिस इज करेक्ट ओनली. Yes, we are talking about the distance, right? So this is correct. Right, so we move to the next question. Yes, everyone. What do you observe? Yes. All right. Yes, guys. So what is the correct answer? Okay, ये देखो, major product of the following reaction. So what do you expect, guys? What can happen over here? Tell me, what is the number of electrons involved in the platinum complex? ये कितने electron species है? Yes, this one platinum has 10 electrons. Okay, plus 4 into 2. So this is going to be how many electron species, guys? Yes, Preeti. Okay, so it is 18 electron species. So it is square planar, लेकिन फिर भी 18 electron species है square planar होके भी. So what is going to happen then, guys? When your molecule has an 18 electron, it is an 18 electron species. तब वो क्या कर सकता है? It has extra electrons, so it can attack the carbonyl carbon, isn't it? So let's say it was a square planar till now. लेकिन after the attack it became something like this. I'm just step by step I'm showing you something. It's not necessary कि mechanism ऐसे ही जा रहा है. It could be a concerted process because it is a double bond, right? But एक बात बताओ, if the platinum has 18 electron, it can attack over this carbonyl and itself get a positive charge, right? तो अब अगर ये ऑक्सीजन यहाँ पे अटैक करेगा, yes, if the oxygen is going to attack over here, then what is going to happen? अच्छा हाँ, sorry हाँ, ये तो electron filled है. The d orbital is filled, so this is going to be tetrahedral. Sorry. Yes. So right, D10 system it is going to be. Yes, yes, zero oxidation state, 18 electrons. तो ये क्या करेगा guys? Tetrahedral से it is going to be 18 electron species. After the attack it becomes something like this. अभी ये O minus है. It is going to attack back on platinum, but is this complex going to be stable? ये देखो, count the number of electrons in this complex. PME3 over here, you are having 4 phosphines once again, ठीक है, and these two donors. All right, मतलब कि one is your oxygen donor, one is your carbon donor. How many electrons are there in this species? Yes, count the number of electrons. If we write it like this, कितने electrons हो गए guys? Already it was 18 electron plus 2 more electron. That is not possible. ये तो possible ही नहीं है बनाना. So what is going to happen? Once it is attacking the carbonyl carbon, one of the phosphine has to eliminate. Yes, extra electrons हो गए यहाँ पे तो 20 electrons. So one of the phosphine has to eliminate for the reaction to take place. So that platinum can react with oxygen and carbon at the same time to give you something like this. Alright, then you have how many electrons in this? EME3 and one of the phosphine is removed. Okay, no problem. तो ये क्या हो गया? 20 इलेक्ट्रॉन होने की बजाय अब ये 18 इलेक्ट्रॉन हो गया. One phosphine is removed. This is an 18 electron species. Yes, but guys, platinum in the 2 plus oxidation state is more stable in the square planar form. So it is going to eliminate one more phosphine and it is going to give you this molecule 16 electron species and square planar. राइट बिकॉज ये देखो क्या है ये नेगेटिव है ये भी नेगेटिव है -1 so platinum is there in the +2 oxidation state. It is going to be more stable in this form as compared to 18 electron molecule, right? So answer is option number 2 for this. Okay, why is this one absurd? ये absurd है क्योंकि carbonyl जो है the carbon oxygen bond, here the platinum is getting inserted. Okay, so this is absurd. This is not going to happen, right? Looks like the opposite of reductive elimination. बिल्कुल नहीं होगा ये. And one carbon only attacking and insertion between the carbon fluorine bond, absolutely not going to happen. ठीक है? So yes guys, only second is the correct answer. Now the major product A and B formed in the following reactions are. So you have the same dithiene molecule and A and B are two different products obtained from the same 1,3-dithiene molecule. Okay, so let's see. Based on different reagents, what are the products? Yes, all of you. All right. Okay, so let's discuss, guys. First thing, in the presence of butyl lithium at -78 degrees centigrade, it is the same. You are going to generate this kind of a carbanion. Okay. So where does the carbanion attack? That is the question. Yes, guys. ये देखो. Can it attack over here or over here? Or is it going to open the epoxide? What do you think? कहाँ पे अटैक करेगा guys? ये थोड़ा सा important question है. Why guys? See, if the negative charge, so you have something like this. If the negative charge attacks over here, then you have one product. और अगर ये यहाँ attack करेगा, then you have another product. So let's say the bromine is the, this is only a primary halide, तो ज़्यादा bulky भी नहीं है. So SN2 reaction, SN2 attack is possible. So let's just try and make the attack possible over here only. यहाँ पे attack करवा दिया, ठीक है? So as it is the epoxide, let's say we are just keeping the epoxide as it is for now. Okay, so this is what you have. और अभी क्या होगा? When the bond is going to be hydrolyzed in the presence of mercury chloride, This is just directly going to give you the aldehyde. How does the aldehyde look like? ऐसा कुछ, ठीक है. The aldehyde is going to look like this or like this. It is the same thing. Now in the first option guys, what do we see? The same dithiene, it is not going to attack over here क्योंकि ये secondary chloride हो गया. Secondary chloride is a little bit hindered for the SN2 attack. And also there is one more possibility. If the dithiene attacks, let's say direct उस पे attack नहीं करेगा because it's a secondary carbon. So let's say for example if the डाइथाइन अटैक्स ओवर हियर लाइक दिस, तो ये क्या हो जाएगा? पेन रीअरेंजमेंट हो जाएगा. आफ्टर द पेन रीअरेंजमेंट दिस साइड द Cl माइनस कैन बी रिमूव्ड, isn't it? Because the difference is only of 3 carbons. ठीक है. So once you see this, you're going to say कि बॉन्ड कहाँ बनेगा? यहाँ पे बॉन्ड बनेगा. And the epoxide is going to shift, isn't it? ये देखो, epoxide has shifted, there is a methyl and this is a simple carbon over here. All right, now after the hydrolysis you are going to get a aldehyde over here on this carbon. How is the aldehyde going to look like? Aldehyde is going to look like this, okay, with the difference of 1 carbon over here. So that kind of pain rearrangement is not possible in option B. Why? Because there is a difference of 4 carbons. ये O minus खुलेगा यहाँ से, तो it cannot make a 3-membered ring over here. Absolutely that's not possible. And also ये जो bromide है ये less hindered है, तो direct attack कर सकते हैं, direct SN2 attack. Okay, so this side is a direct SN2 attack type of reaction and this side is the pain rearrangement. Okay, so answer is option number 1 itself. Yes, what's wrong in 3 guys? 3 में क्या गड़बड़ है? देखो यहाँ पे rearrangement नहीं हुआ. The rearrangement is not taking place in 3. That is not going to happen. Okay? Yes, there will be rearrangement. इसलिए 1 is the correct answer. So yes guys, we move onwards. Next important question. The structure of the compound which displays the following spectral data is. So what is the correct structure according to the given set of data? Yes. All right. 1690, what does it say guys? 1690 and 1100. ठीक है, तो 1100 is of less importance, लेकिन 1690 तो है. That is, you are having an ester and that also some kind of a conjugated ester. ठीक है. So the conjugation must not be on the oxygen side. उससे क्या होता है? Frequency increases. So this is going to be around 1760 for the carbonyl. Absolutely does not qualify 1690. Yes, ये तो ester है ही नहीं, and this is a extensively conjugated ketone, which means it is going to be, yes, very less than the for normal value for ketone is around 1715. ठीक है, अब ये तो बहुत ज़्यादा resonance है, so this could be 1690. Yes. And what about this? This is a conjugated ester. This is only going to be 1720 या 1715 कम से कम, उससे कम नहीं होगा, right? And what about this guys? Once again, it is a ketone which is conjugated. So this could also be 1690 or something close to that. ठीक है? चलो. So 1 and 2 are wrong. 3 and 4 could be correct. But we move onwards. Achha, what is 1100 for? The 1100 value, it is for the carbon oxygen ether linkage. This is for the carbonyl and this is for the ether linkage. ठीक है? Yes, Monica explained this chemical shift. See, what happens is, Monica, whenever you are having resonance towards the carbonyl, then in the ester specifically, then the carbonyl bond order is decreasing, no, directly, direct resonance into the carbonyl. So the carbonyl bond order decreases. When you compare this with a simple ester like this, ठीक है, ये simple ester है, तो simple ester के लिए 1735 is the value. Okay, so when there is resonance, bond order decreases, and that is why the frequency of carbonyl also decreases. Decreases by how much? Approximately 15 to 20. ठीक है, so 15-20 centimeter inverse से decrease होता है, that is why we say approximately 17-20. ठीक है, it could be 17-15 also, doesn't matter. ठीक है, why did I say that on resonance towards the oxygen side, let's say एक resonance oxygen के side पे है, how is it going to cause any difference? जो ऑक्सीजन यहाँ लोन पेयर दे रहा था, that lone pair is now going to resonate in the other double bond, which means that the bond order of this carbonyl is going to increase, क्योंकि यहाँ पे क्या हो गया है, divided resonance हो गया है, not enough resonance from this oxygen. So that is why the bond order increases, because the oxygen has to distribute its electron density between two double bonds. Okay, so bond order increases and the carbonyl stretching frequency also increases. 1760. ठीक है, अच्छा ठीक है, all right, we will discuss all of the values, no problem. सारे values discuss कर लेंगे. um, let's first discuss this one thing, that let's look at the proton NMR value 2.8. See, first thing guys, if you are given the aromatic protons, तो aromatic proton को देख के find out करो कि para substitution है कि ortho है, let's say 6.9 doublet. So if there are two hydrogens which are doublet, two hydrogens doublet, which means that there is a sigma plane in the molecule. This hydrogen is a doublet because of splitting by the neighboring one. कितनी वैल्यू आएगी इसकी? इसकी आएगी 7.8, क्योंकि ये कहाँ है? Beta position to the carbonyl, so more electron deshielded. This one is going to be 6.9. This is electron rich because oxygen is giving electron density. Okay, so only two values in the aromatic region, which means para substitution. तो वैसे भी 4 को cancel कर दो guys, तो एक ही तो बचा ना. Just looking at the IR value and just looking at the aromatic proton value, you confirm your answer, it is 3. If you further want to check, not a problem. 2.8 3 hydrogens is going to be for the methyl, and 3.8 singlet is going to be for the ones connected to oxygen, this methyl. Okay, that's the answer. All right, and how can you define the proton NMR values? Yes, Monica, if you're asking ki ma'am, only based on proton NMR, can I cancel out 1 and 2? No, absolutely not. You will be confused. Okay, you will be confused. You cannot cancel out these two options based on the proton NMR value. You have to do that based on the IR value only. Okay, otherwise you will be confused, because it is the same para substitution and more or less the aromatic protons are going to be similar. You cannot predict that. Okay, yes. Okay, all right, Green. So I got your comment. I will try to discuss this in the next session, but अभी फिलहाल तो practice चल रही है. Okay, so yeah, let's do another question. ये देखो, true statement regarding Hammett reaction constant rho for the following transformation is. Yes, guys, nice question. Rho is the reaction constant, isn't it? ये तो reaction constant था. And when the reaction constant is positive, you say that the transition state is electron rich. And when the rho value is negative, the transition state is electron deficient. Okay. So here you see that the tetrahedral intermediate is going to form and it's finally going to give you the carboxylate क्योंकि base catalyzed mechanism है तो base catalyzed mechanism में it is always going to give you electron rich tetrahedral intermediate, which means that for both the reaction the rho value is going to be positive without any doubt. Yes, you can see that. So negative वाला जो option है, this is going to be wrong. Okay. Now, what about greater positive, less positive, guys? Yes. So, when the ester group is directly connected to the benzene nucleus, and guys, ये जो X है, X का effect benzene के ऊपर होता है because वो directly benzene से connected है, right? Connected to benzene, and the effect of X will only be felt on the ester group when it is in conjugation like this, okay, when it is directly connected to benzene, and the effect of the X group will be felt very poorly if it is just away from the benzene, 2 carbons away, no resonance possible. So even though it is a positive value for both of them, the effect will be felt higher for this, so this is going to be a greater positive value. Rho for A is a larger positive value than for B, so 3 is the correct answer. ठीक है? Yes. All right. So all of these questions are really important, guys, and ये concept repeat होते हैं हर बार. And definitely this is Thursday. You have also got sessions on Friday and Saturday, as I've already told you. तो Friday और Saturday को भी हमें क्या करना है? Join करना है on the same time, that is the 6 p.m. या फिर 6:05 p.m. Okay. And the link I will definitely share on the Telegram group CSIR NET 2022. Okay, so you can join the Telegram group over here, guys, and don't forget to use the code Jagriti S Live for subscribing. And right now you are having a 20% off offer going on by using the same code. So, which topic tomorrow? Yes, actually, Christ, we are just doing a miscellaneous question answer series, so going to be mixed questions. Okay. All right, Ayush, that's great. Thank you. Yes. Okay, guys. So have a nice evening, all of you. Bye, everyone. Take care of yourself. I'm going to see you really soon tomorrow. Bye, guys.